Now that we know that what TOR is, we will discuss the working principle of TOR. Now, TOR works on the principle of onion routing. As onion has multiple layers, so does the data in the TOR network. The data is encrypted in multiple layers in order to be transferred to the server. Now, TOR, the main purpose of TOR is to protect the identity of the user online, and it does so by encrypting the traffic in at least three different layers and then passing it through a chain of volunteers. And mostly, it is three different volunteers that are randomly chosen from a large number of volunteer computers from around the world. It After choosing these three volunteer computers, the traffic is passed through these computers, and the traffic bounces back and forth through these volunteer computers. Now, as you can see that there are three type of relay nodes in the network. The first one is entry node. Entry node is the one that communicates directly with the client. Then there is a relay node. It is known as the middle node as well, and it never communicates either with the client or the server. It only communicates with the nodes, either the entry node, exit node, or the middle nodes. Now the third type of node is the exit node, and it communicates with the directly with the server, and it is the most prone to legal implications, as this is the IP address that will be received for the request made to the server. Now, the volunteer nodes that are used in the TOR network can be individuals, they can be companies or universities. They are just the normal computers, and each TOR message is known as a cell, which is of 512 bytes, and it constitutes of a circuit ID. Now, in order to access a website through Tor, instead of directly establishing the connection with the web server, the client will make a request to the Tor directory. Now, Tor directory will have the records of all the volunteer nodes. It will choose three nodes at random and establish a circuit by which the communication will take place between the client and that server. Now, after the circuit has been decided, the nodes have been decided, the client computer will have TLS sessions. Now, TLS is transport layer security, which we have already studied, with each of the three selected relay nodes. And as a result of these TLS sessions, a symmetric encryption key is generated, which will only be known to the client and the specific relay node. Now you can see that as a result of the TLS session between T1 and client A, the blue key has been generated. This key is known only to T1 and the client A. Now after the communication with T2, TLS session with T2, the pink key is generated and it is only known to T2 and the client, and so is the case with T3. The client will know about all the keys, whereas the nodes will know only about the key that was generated during their TLS session. Now the data is encrypted in n layers, where n is the number of relay nodes, which here is 3. The nodes, as already discussed, only know about their respective keys. Now for a three-node circuit as the one here, first the client will gather the data that is to be sent to the server. The initial data the initial packet will have the source IP address of the client, which is A, and the destination IP address of the server, which is B. Now, the first change which will be made is that the source IP address A of the packet will be replaced with the IP address of the exit node T3. As you can see, this packet will be made after replacing the IP address of the client with the IP address of T3. Now, this packet will be encrypted using the symmetric key that was generated by the TLS session between the client and the exit node T3, whose source IP has been written over here. Now, after encrypting this packet, this whole packet will act as data for another packet. Now, this packet will have the destination address of which will be the same as the source IP address of the last packet, which we have encrypted, and the source IP address will be of the middle relay T2. Now, after assigning the source and destination IP addresses to the packet, we will again encrypt this packet for the second time, and now this packet will be used as the data, and the destination IP will be the source IP of the previous packet, and the source IP will be the IP address of the entry node or the first node of the network. Now, after this packet has been made, we will again encrypt it for the third time, and using the encryption key that was generated during the TLS session between the client and the relay node T1. Now, after this packet has been encrypted, now the destination IP will be of the source IP of the previous packet, and the source IP will be that of the client. Now, this packet is ready to be sent to the network. Now, how this packet will be sent is that first this packet will be sent from the client to the node T1. After sending this packet to T1, T1 will use its symmetric key and it will decrypt this packet using the symmetric key. After decryption, it will receive this packet and it cannot decrypt it because it does not have the pink decryption key. It sees the destination IP address, which is T2, and it passes the packet on to T2. When T2 receives this packet, it knows that it has the decryption key for this. It will use the key and decrypt this packet, and then it will get the red packet. It will see it cannot decrypt this packet. It will see the destination IP, and destination IP is of T3. So it will pass on the packet to T3. When T3 receives this packet, it will decrypt this packet and it will receive the first packet, that the green one. On receiving this, it will see that this packet has to be sent to the server. It does not know it's a server or what. It will see that it needs to be sent to the IP address B. So it will send the packet to the IP address B. On receiving this packet, the server will process the request, and after generating the output for it, the response for it, the server will again send the response back to the client through this network. It does not know that the request has been made by A, but it thinks that the request has come from T3. So it will send it to T3. T3 will send it back to T2. T2 will send it back to T1, and ultimately it will receive the client A. So, in this way, the communication takes place in Tor network. The basic principle of encrypting it in multiple layers is that no node, not even the server, will know about the IP address of both the client and the server. Only the client will have knowledge about the IP addresses of both the client and the server, and no other node. So this was all for the working principle of Tor. Next, we will be discussing some hidden services that are used for Tor.